All right, hello and welcome to part 2 of 9411. We're going to start this one off by talking about quartiles. Quartiles just divide a data set into 4 equal parts. So then each quartile contains 1/4 of the values, okay, in the set. Or in other words, 25% of the data. So you just take a bunch of values and you split it up into 4 equal parts. The interquartile range is just the difference between the upper and lower quartiles. Okay, and that's going to make more sense here visually in a second when I show you an example. The IQR just represents the middle half of the data. So it represents the 25% of the data above the median and then the 25% of the data below the median. So here's a visual representation of what we're talking about. You can see here that your median is 5, right in the middle. Now to find your quartiles or to split up into fourths, you need to find the middle of the bottom half of the values and the middle of the top half of the values, okay? And this middle number of the bottom half, we actually call Q1. Okay, that number is called Q1. You can see here it says the median is 5, but it also says Q2 in parentheses. Sometimes we call the median Q2. And then the middle of the top half of the data we call Q3. Okay, so it's split up into quartiles. Here's 25% of the data, here's 25% of the data, 25% and 25%. Okay, so they're split up into four different parts. You can see your range is taking the largest number 9 minus your smallest number 1, and that's 8. But your interquartile range is taking your Q3, which is 7, minus your Q1, which is 3, and that interquartile range is 4. So sometimes I will ask you to find the range, sometimes I will ask you to find the interquartile range. It's helpful to note that mathematically any value that is 1.5 times the IQR, less than the first quartile, or 1.5 IQR greater than the third quartile, we consider an outlier. And an outlier is just a value that's really different from your other values in the set. Okay, so in this one, we have a bunch of low values, and then we just have one value way out here that is much, much higher. That we call an outlier, okay? And we can mathematically confirm that it is an outlier by doing this 1.5 times IQR, which I'll show you here in a second. We are going to use all of this information to draw a box and whisker plot. A box and whisker plot is essentially just a visual representation of how values in a data set are distributed, okay? So we have the minimum, which makes sense that it would be the least value in that set. And then the maximum is going to be the greatest value. We're going to need to know those two things. In order to do a box and whisker plot, you are going to need what's called the 5-number summary. The 5-number summary, I would write this down, is made up of the minimum, the first quartile, or in other words Q1, the median, the third quartile, or in other words Q3, and then the maximum. Those are the 5 numbers within the 5-number summary. Okay, so let's try it ourselves. So we can find the Q1, Q2, or sorry, we're going to start with the minimum. We should start by listing the minimum. The minimum, Q1, the median, or in other words Q2, Q3, and the maximum. Those are the 5 numbers in the 5-number summary that you will need in order to construct a box and whisker plot. Okay, and to save us a little bit of time, I've lined these up from least to greatest so I can find the median. So I'm going to start by crossing off values from left to right here. And I'm not actually crossing them off because I still want to be able to read them. Okay, until I get all the way to the middle and I find that 10 is going to be my median. Okay, and I can actually already identify my minimum, which is 3, and my maximum is 20. I just need to find Q1 and Q3. Now Q1 being the middle of the bottom half. So I'm going to start crossing off values in the bottom half to find Q1. And I find Q1 is 6. And I can do the same thing in the top half. I should circle this. Okay, I can do the same thing in the top half to find my Q3. And it looks like Q3 is 12. Okay, so that is how you would find your 5-number summary. We should check to confirm that there are no outliers because 20 seems like a really high value, but we're just going to confirm that it is not an outlier. So I said to be an outlier, you need to check, first you need to figure out what your IQR was. So we're going to take 12 minus 6, and your IQR is 6. Now, in order to be an outlier, you've got to be 1.5 times the IQR, in other words, 1.5 times 6, outside of Q1 or Q3 to be an outlier. So the number 9 is what we're going to be working with to find if we have outliers. So we're going to take our Q1 value, which is 6, okay? And in order to be an outlier, your minimum or your smallest value has to be 9 less than your Q1. So 6 minus 9 is -3. Good news, we don't actually have any values that are less than -3. So we're in the clear there. Now let's take our Q3, which is 12, and let's add 1.5 times the IQR onto it, so 9, and we get 21. Luckily, we don't have any values that are greater than 21. So we really don't have any values that lie outside of -3 or 21. So we don't have any outliers. Okay, so we did identify our minimum, Q1, median, Q3, and maximum, which is going to help us create the actual box and whisker plot. So let's fill this in again. 3, 6, 10, 12, and 20. Okay, so minimum being 3. You are going to put and let's just label this as 2, 4, 6, 8, 10, 12, 15, 16, 18, 20, 22. You're going to put a dot at your minimum. So 3 is right about here. I'm going to put a dot at 3. And I'm going to put a dot at my maximum of 20 as well. Okay, and then you're going to put lines where your Q1, median, and Q3 are to create your box. So my median is at 10. So I'm going to draw a line at 10. My Q1 is at 6. I'm going to draw another line right at 6. And my Q3 is at 12. So here's 12. And I'm going to connect these and make sort of a box shape. And then you can take your Q1 and connect it by a line to your minimum. Same thing here. Use a line to connect. Now it's called a box and whisker plot because literally you have box and then you have 2 lines that come out and look like whiskers. So this is just a visual representation to say, hey, this lower half of the data, here's 50% of the data, that seems pretty squished in together, maybe compared to the top half of the data, the top 50%. Or you would say, wow, your Q2 has a much bigger spread than your third quartile here, your Q3, okay? So let me just label this Q1, this is going to be Q2, this is your third quartile, and this is your fourth quartile, okay? I hope that notation wasn't confusing that I'm using Q's, even though this is Q1 right there. I probably should say first quartile and actually write it out instead of using these Q's. That gets confusing because this is your Q3. That's your Q1. Okay. And just a quick note, if you do have an outlier, you are not going to connect it to your box and whisker plot. You would have a box and whisker plot that looks like this. Here's a whisker. I might have a box that looks like this, right? And then if you have, let's say you have an outlier that's really high, you're just going to represent that using a single dot. So when you're quickly looking at this, you can say, oh, hey, here's your median. you end your maximums here, but then you've got this outlier way up here. So the dot just tells the reader that there's an outlier in your data set. Okay, and that is the end of part 2.